Example 2, we have time it takes an object to hit the ground. A roofer drops a hammer from the top of a 64-foot roof. The height of the hammer after t seconds is modeled by the equation given. When will the hammer hit the ground? Okay, so you got somebody standing on top of a roof. They drop their hammer. Whoop. And we want to know, when does it hit the ground? So, if this equation models the height, what is the height at the ground? The height on the ground is going to be 0. That's why the hammer stops, because that's it. There's nowhere else to go. Okay, so what they're telling us is if the height equals 0, when will the hammer hit the ground? So what is the time that happens, t? All right, so let's make h 0 in this equation, negative 16t squared plus 64. And this is a quadratic equation, degree 2. So that means we want 0 on one side. Great. And we want to completely factor the other side. So first term is negative. There's going to be a negative GCF here. And it looks like 16 is the greatest common factor. So let's factor that out. We'll divide from both of those terms to see what remains. For the first term, that's going to be a positive t squared. For the second term, that's going to be a negative 4. And we want to see if we can completely factor this binomial. This is a difference of two perfect squares, so it will have the sum and difference factors of the first term t and the second term 2, because 2 squared is 4. And then any factor containing a variable set equal to 0 by the zero product property. If we set negative 16 equal to 0, that doesn't get us an answer for the variable. It doesn't have a variable in it. So let's solve those resulting equations by oppositing those number terms. So t equals negative 2 and t equals positive 2. Okay. And let's see. The question is, when will the hammer hit the ground? Does it make sense for us to say after negative 2 seconds? No, that doesn't make sense. So we're not going to use that solution. Even though it's an answer to the equation, it's not an answer to the problem. How about 2 seconds? Does that make sense? Yeah, after 2 seconds, the hammer will hit the ground. That answers the question there. Does it seem reasonable? We can definitely check it if we want to put that in the equation for t and see if we do get 0. So that will be negative 16 times 4. And that does add to 0 if we want to check that solution. So the thing here is to remember that even though your solution to the equation works, it doesn't mean it's a solution to the application. It's got to make sense in the real world. You can't have a hammer hitting the ground at negative 2 seconds. It's just not possible.